Good morning, GS student. This is your math teacher, Monsieur. I hope you are all safe. Our lesson today is also about inverse trigonometric function. In fact, I'm going to solve an exercise with multiple choices. But first of all, we must remember that radical integral of dx over radical 1 minus ax plus b square equal 1 over a arc sine of ax plus b plus c. Also, integral of dx over radical a square minus a square x square equal arc sine of x of a plus c over a plus c. By using the relation integral u prime over radical 1 minus u square dx equal arc sine of u plus c, in fact. And the last two formula here, I have dx over 1 plus ax plus b square equal 1 over a arc tangent of ax plus b plus c. Also dx over a square plus x square equal 1 over a arc tangent of x over a plus c by using u prime over 1 plus u square dx equal arc tangent of u plus c. The first question here is about finding the domain of definition of the function g of x equal arc cosine 2x square minus 1. First of all, you start by yourself. We have here 4 possible answers. Okay, what is the solution? You should solve it by yourselves, but I'm gonna give you now the answer. You can pause the video, solve it, then check up your answers. First of all, we remember that for arc cosine of t, this is defined for t belongs from minus 1 till 1. So minus 1 less than or equal t less than or equal 1. So I can deduce in this case that 2x square minus 1 is between minus 1 and 1. Now if we add 2, I need to know the x is bounded by what. So first of all, I add 2, we obtain 0 less than 2x squared less than 2. Then we divide by 2, we obtain 0 less than or equal x squared less than or equal 1. In fact, this is equivalent to say that absolute value of x is less than or equal to 1. So I can deduce that x between minus 1 and 1 also. So the correct answer is that the domain of definition is from minus 1 between till 1. The second question is, if g of x equal arc tangent of x plus radical 1 plus x squared, then g prime of 0 equal what? We have also 4 possible answers, 0, 1, 2, 3. As I said in the previous question, you can pause the video, try to solve this question by yourselves, then you can see the correct answer here. Now, first of all, we remember that g prime of x equal u prime of x over 1 plus u square plus x, which is the derivative of this relation of arc tangent of u. The derivative is u prime over 1 plus u square. Now, u prime equal the derivative of x plus radical 1 plus x square prime equal 1 plus 2x. We know that derivative of radical u, its derivative is u prime over 2 radical u. So here we use this relation, u prime, it will be 2x over 2 into radical 1 plus x square. Then g prime of x, which is u prime over 1 plus u square, becomes 1 plus x over radical 1 plus x square over 1 plus x plus radical 1 plus x square, all of it square. So if we substitute x by 0, we obtain half, and this is the correct answer. The third question, they ask us to simplify this relation. We have cosine of 2 arc cosine x square equal what? Which of one of the following? Now I remember that cosine of arc cosine of x equal x. What I'm going to do now, also start, I'm going to show you the answer now. Let alpha equal r cosine of x square. Then cosine of alpha, we take cosine alpha here, we obtain cosine of alpha equal cosine square, since cosine of r cosine of x equal x. Then we obtain, I replaced here r cosine of x square, as I said, by alpha. So this is, I have here, this is r cosine x square, which is equal alpha. We obtain cosine of 2 alpha, but we remember that cosine of 2 alpha equal to cosine square of alpha minus 1. But cosine of alpha equal x square, so I can replace cosine of alpha by x square. So we obtain 2x exponent 4 minus 1. What about this question? They ask us to determine the equation of the tangent to CF at its point of abscissa 0. So we remember that the equation of the tangent is T y equal f prime of xa, if the required point is xa, into x minus xa plus y of a. Here this is x of a, I'm sorry for the bad handwriting. So now we obtain, the answer is, we have here 4 proposed answers, but the answer in fact is here. Since f of x equal x plus arctangent of x, I need to determine first of all f of 0, which is 0 plus arctangent of 0, which gives us 0. Then the point A, the coordinates of the point A, the required point are 0 and 0. F prime of x, the derivative of x is 1. The derivative of arctangent of x equal 1 over 1 plus x squared. So f prime of 0 equal 2. So here I have y equal f prime of xa into x minus xa. This is 0, this is 0, and this one is 2. So the correct answer, y equal 2x. This question we can directly use the formula. I think I have from 0 till 2 integral from 0 till 2 of 1 over radical 1 minus x squared dx. So the proposed, we have here 4 proposed answers. I think this is directly we can apply the rule. I know that dx over radical a square minus x square equal arc sine of x over a plus c. So we can apply it here. It will be arc sine of x over 2. Of course, from 0 to 2, by substitution, we obtain arc sine of pi over 2. And the last question here is, if I have from 0 to 2 integral from 0 to 2 of x plus 1 over 4 plus x squared dx. And here I have 4 proposed answers. The answer is, first of all, I can separate this integral x over 4 plus x squared from 0 to 2 dx, and from 0 to 2, 1 over 4 plus x squared. First of all, the first question we use a convenient change of variable. I noticed that here it can be the derivative of the denominator, so I can add here 2 and divide by 2. And then we use the change of variable. I can replace 4 plus x squared by u, du equal to x dx. For x equals 0, u equal 4. For x equal 2, u equal 8. So the answer of this integral becomes, I have here 1 over u du, which gives us ln of u, of course ln of absolute value of u, but I notice here u is between 4 and 8. There is no need for the absolute value. The final answer here, ln of radical 2. And the second one, we can apply directly the formula. We obtain 1 over 2 arctangent of x over 2 from 0 till 2, and the answer will be pi over 8. Then the correct answer is integral 0 to of x plus 1 over 4 plus x squared dx equal pi over 8 plus ln radical 2. That's all for today. Thank you.